Okay, let's go ahead and get started. Okay, so we're going to be talking about evolution of HTTP. I am Anantaraman Subramanian, that's my full name, and I go by Anant or Ram, and I am a UTD alumnus myself, and I got my master's in computer science from UTD like 9 years ago, and currently I am the lead front-end engineer at Axxess. And that is my Twitter handle. I generally post technical content that's related to front end or C# or anything that's tech related. I generally post it. So if you want to follow me, that would be my handle. So what are you going to sit through today? Well, we're gonna, since this topic is about evolution of HTTP, we're gonna go over the basics of HTTP, and then the different versions that are there in HTTP. And we're going to primarily focus on HTTP version 1.1, 2, and a small demo that shows the difference between 1.1 and 1.2, like how things have changed between 1.1 and 2. And we'll also look into HTTP version 3, which was introduced very recently, and we'll talk a little bit more about that too. So moving forward, so the first thing, before we start talking about evolution of HTTP, I thought we should go and just understand some basic concepts in HTTP. So let's go ahead and see what HTTP is. HTTP stands for Hypertext Transfer Protocol. It was initiated by Tim Berners-Lee in 1989, and that's him. That's his picture. And it is an application protocol. HTTP is an application protocol, and HTTP basically powers the internet. Every communication that happens on the internet, well, it follows the HTTP protocol. And the next concept that is part of HTTP basics would be the HTTP messages. So think of it this way. These days, we cannot go to restaurants because, well, of the whole pandemic situation. So you call a restaurant, you would like to order food, and you call them and you speak to them in English. But in order for the restaurant to take the order, the person who's talking to you should understand English as well. Similar to that, applications on the web communicate using HTTP. And HTTP messages are like, you can say like words, that's how you communicate between each other. So simply put, HTTP messages is a request response protocol. So it's like saying, hey, give me this resource. And the response will basically say, take this resource. That is what, that's a quick picture of a client, which is like a laptop and a server. So the client is asking for something and the server responds with it. So there are two types of messages, only two types of messages. One is the HTTP request, and the other is HTTP response. So moving on. So that is the basics, some basic concepts of HTTP, something we need to know to understand the different versions in HTTP. So jumping into HTTP versions, HTTP has changed over the years. And a lot of improvements have been made, and that's how it evolved. It evolved through the versions. So we're gonna take a look at how it evolved and what time it evolved, and what were all the features and improvements that were introduced after each version. So this is a quick timeline on the evolution of HTTP, or the different versions that were introduced. So in 1991, HTTP version 0.9 was introduced. And after 5 years, HTTP 1.0 was introduced. And in 1997, HTTP 1.1 was introduced. And nothing changed, for about 16 years. We stayed with 1.1. People found workarounds and they stick with it. Now in 2015, they decided, all right, it's time for a new change. So there was a new version, HTTP 2. But within 3 years, now we have HTTP 3. And with all the growth that's happening, so many changes that are happening in the world, I believe there will be more versions of HTTP in the future. Okay, so let's get a quick view. I know I said we'll primarily focus on HTTP 1.12, but let's get a quick overview of what was there before HTTP 1.1. Since there are only 2 versions, I'm going to quickly go over that so that we get an idea of why things moved in a certain way, the way they moved. So to begin with, the very first version, which is 0.9, it was a very simple protocol. All it was used to do was fetch a resource. There was nothing else you could do. And you can only fetch one type of resource, that is a HTML file. So that is it. There was nothing else. It was a very simple protocol. And after some time, people thought, you know what, there is more potential to the web. There is more potential to the internet. We don't have to restrict ourselves to just one type of resource. So that's when content negotiation was introduced. And for the first time ever, multiple requests to load a single page were possible, which turned out to be both a pro and a con. And there were machine-readable error detection. So in 0.9, you cannot read errors. The machines, like for example, an application cannot read the errors. Like the coders have to go through the HTML file to know, hey, whether the response was a success or a failure. And again, content other than HTML can be requested, like images. The request that you see is actually, you see that we're actually requesting a GIF image. And, there were some headers that were introduced. And the response, we were able to get different types of responses. And also, we were able to do, because multiple requests were requested, we were able to open and close connections on each request. Status code and reasons is how machines were able to detect whether the response is a successful one or a failure one, which were introduced as part of 1.0. And there were more headers that were introduced in request and response, which enabled the possibility of content negotiation between 2 applications. So things got better, but yet not perfect. The thing is, none of these were standardized. Till HTTP 1.0, all of these changes were still not standardized. So that's when HTTP 1.1 came in. People decided, it's time we had a standardized protocol. So HTTP 1.1 is the very first standardized protocol. It is widely used. It is still in use. Just because there are newer versions, that doesn't mean it's not in use. You can still choose to use 1.1. And a lot of applications out there still use 1.1. And 1.1 basically fixed all the problems that were in HTTP 1.0. And it also gave some additional features like requesting language. Previously, it was just English. Now you can request French, Spanish. There are so many languages that you can request. And it also introduced the possibility of compressing your response. So this was a very big deal because we want speed. Internet these days, or over the years, people wanted content to be faster. So response compression is one thing that definitely helped with the speed of the internet, or sorry, speed of the response. Okay, so we were in a good place with HTTP 1.1, but applications became more complex. Initially, things were like the image that on the left, and then there was MySpace. You see how many links there are there within MySpace, and so more resources were needed. So that means when more resources were needed, more requests were made, which eventually made the websites slower. So in the early days of HTTP 1.1, websites actually did not make a lot of requests, like that XKCD website. It's probably made like 2 or 3 requests and it was good to go. And opening and closing TCP, the connections to make each request. So let's say if you load a page or load any application or your app, you are requesting 2 or 3 resources, it's fine, not a problem at all. But as you keep requesting more resources, so you request more, in that case, that means we're looking at more problems, primarily on the performance of the page or the application itself. So one of the key features that HTTP 1.1 introduced was persistent connections. So persistent connections, in order to describe persistent connections, one thing that we need to understand is that with HTTP 1.0, whenever I have to, or an application has to make a request to its counterpart, first it has to establish a connection with with the other application. And then every time it establishes a connection, it'll make a request. And once it gets the response, success or failure, it'll close that connection. So whenever it wants to make the second request, it'll start the same process again. It'll open the connection again, make the request, get the response, close the connection. So this was, this with the world moving towards wanting more requests, this added a lot of overhead because internet right now, or HTTP 1.1 uses TCP connections. For TCP, there was a handshake, which basically before even making a request, it makes 3 different like round trip with between the applications before it forms a connection. So in order to, if you have 10 requests, that is 30 extra round trips between the 2 applications, which is a huge overhead. So the solution that HTTP 1.1 introduced was persistent connections. Persistent connections are basically, you have one connection and you keep that connection alive. So by default, any connection that you open, it will be kept alive, unless either of the applications decide to close it. The control is on both sides. Either application A can decide to close it or application B can decide to close it. Because of this, the performance improved a lot because we have reduced a lot of overhead. So this was one really good feature that was introduced as part of HTTP 1.1. But experts forethought that we will need more connections. One connection is not enough. What if there is a possibility of making parallel requests? So they basically added in the spec saying you can have a maximum of 2 parallel keep alive connections to the same host. So host here means like google.com or wehackutd.com. So this also reduced the load time even more because now you can request 2 resources at the same time. But this is still not good enough because, like I said, applications, there are websites or applications that make hundreds of calls just to load their initial state of their application. So browsers said, you know what, we're not going to follow this spec anymore. So they increased the number of parallel connection limits. And you can see how they increased it. Like Internet Explorer went up to 8, Chrome and Firefox, they decided to go for up to 6, and Safari, decided to give up to 4. So this is great. Now I can make multiple requests at the same time. And this will definitely improve the performance of my application. Okay, fantastic. But this is still not enough. If you're going to make 100 requests to load your application, this number of parallel connections still doesn't help you. So what did people start doing was they started finding workarounds. So one of the workaround is domain sharding. So as we looked at before, the number of connections, the maximum number of parallel connections you can have, the limitation is actually per host. So the host is, like I said, it's google.com or wehackutd.com. So domain sharding is basically saying, I'm going to split my website into these parts. Like as you can see in the picture that I have, they split their site. So domain.com is the example here. And what they did was they split their UI into static1.domain.com, static2.domain.com, and static3.domain.com. Because they did this, all of those hosts will point to the same server address. But even though it did that, according to the browser, it's a new host name. So because of that, it allowed 6 new connections for each of those hosts. So now the website is able to make, in this case, domain.com can make up to 18 connections, 18 parallel connections to get their resources. So, this is one way to improve your performance in with HTTP 1.1 that people found a way to do it. And one other thing that you could, that anyone could do is reducing the number of requests, and which is not always easy, and it's a lot of work, but still, you still want your website to perform at the fastest level possible. So more workarounds were introduced. Sprite images, like images were combined into one giant image, and when they're displayed, they displayed using CSS, which is positioning it to that location and displaying it. Concatenating files. Instead of having 10 files of the same type, they merge them into one file and they sent it so that you don't have to make 10 requests, you just make one request. And they inlined a lot of the code within a single file to reduce the number of requests. So these are all workarounds that were part of HTTP 1.1. So as you can see, as time went by, more requests were there, websites were getting complex, so websites are getting sophisticated. There were more good features that were being introduced, but that complicated things. So in order to reduce the complication, there were a lot of workarounds that were introduced in 1.1. So this is when people decided, okay, these workarounds are too much. These are a lot of overhead. So how do we fix this? That's when HTTP 2.0 was introduced. HTTP 2.0 is not a replacement of HTTP 1.1. It is improvement to HTTP, it is to solve all the workaround problems. HTTP 2.0 essentially removed the need for all the workarounds that we just discussed, like domain sharding, the image spriting, concatenating, and inlining. HTTP 2.0 was derived from Google's Speedy protocol. And also, the number of parallel connection limit was completely removed in HTTP 2.0 spec. So since the browsers didn't care anyway, but they still had a limit, but the spec went ahead and said, we set 2, now we're saying there are no limits at all, just go have fun. So some of the benefits that HTTP 2 introduced or solved, how it solved the workarounds that were taken in HTTP 1. These are some of the features that were introduced which solved those problems. So binary protocol, instead of a text-based protocol, HTTP 1 was still text-based, and binary protocol was introduced. Multiplexing, we'll look at what multiplexing is and how awesome it is. And header compression is always good. It always reduces the amount of data that you're transferring between 2 applications. Server push, it is one of the most wonderful features that were introduced as part of HTTP 2.0, and we'll go over that as well. So now jumping on to the next topic, which is actually seeing how these concepts that were introduced as part of HTTP 2.0 made the web better. Okay, so the first thing, binary protocol and multiplexing. So if you focus your attention to the image on the right, with HTTP 1, whenever you want to request a resource, you can only request one resource at a time. What do I mean by that? With TCP connections, you make one request, and then you get a response, and then only you can make the second request. And only when the second request comes back, you can make the third request. So with HTTP 2, because of binary protocol, the request is not text-based. It was first converted to a binary version. So they introduced this new layer called a framing layer, which basically translates the request to the binary protocol. And because of the binary protocol, we were able to merge multiple requests into one request. And this one request, when it's sent to the server in this case, it's fine. Now you have this capability of requesting more than one resource in one connection. So because of this, there is no need for domain sharding anymore. You don't have to do domain sharding. You don't have to do concatenating. You don't even have to do the sprite image because things are much faster now. Because with just one request or one connection, you're able to get all the resources back. So this is one of the biggest improvements that were introduced as part of HTTP 2.0, which solves, which prevents a lot of workarounds that we have to take in HTTP 1.1. And header compression. So header compression, okay, roll back a little bit. In HTTP 1.1, we were able to compress the bodies in the sense the content that was being sent as part of the response. We were able to compress that. That was introduced as part of HTTP 1.1. Now you can also compress the headers as well. Both the request and the response has headers. Now we are able to compress it. So this way, less data is being transferred both ways. And the compression is mainly on the redundant header frames. So when there are multiple requests that are made, there will be some data that are redundantly being sent. So what happens is that both the server and the client caches some of those redundant data, and they're being used through the compression technology. The technology that's being used is the HBAC specification, and I don't know. Yes, HBAC specification, sorry. So the last but not least, this was an addition to HTTP 2.0, which the feature is the server push. So the first benefit is the unsolicited content, which is, so we're going to take a look at how HTTP 1.0, how things were without server push and how things would be done with server push. But unfortunately, server push is heavily underutilized because the amount of effort taken to switch to server push is tremendously high, and the cost is also very high. So not a lot of organizations have adapted to server push. But regardless, we will see the benefit of server push, works. Okay, so this is how a page loads with no server push. So we make a request for a HTML file, you get back a HTML file. Then you request for a CSS file, you get back a CSS file. Simple, right? So what happens with server push? Well, the server becomes a little bit more smarter. So we request the HTML file, and within the HTML file, the server will basically say, hey, in your HTML file, there is a reference to the CSS file. So when I send this back, you're going to request the CSS file. So why don't I send this beforehand instead of you requesting it? So as you can see, when the first request was made, there were 2 responses that were sent back. And what will happen is the client will basically cache the CSS file. And when it actually wants the CSS file, it won't go to the server because it will just go to the cache and it will fetch it. By this, you're improving the performance dramatically. So I'm going to show a quick demo of how this, the quick difference between HTTP 1.1 and HTTP 2.0 to see how better they are. Okay. So I'm going to exit out of the presentation real quick. Okay, I'm going to refresh this page to show you the difference between HTTP 1.0 and HTTP 2. So as you can see, so at the load time, there is definitely a difference. And if you go and inspect the elements, you can clearly see the difference. I don't want to do this. Sorry. So with HTTP, so Akamai, they built this 2 simultaneous requests, one with HTTP 1, an image loading with I think 300 tiles, and one with HTTP 1, 1.1, and the other with HTTP 2. So with HTTP 1.1, you can see there were some parallel connections made, but you can see that there is a time difference. But with HTTP 2, you will see a lot of the calls slow. So I'm going to try to focus this a little bit. Okay, you see a lot of the calls were made at almost the same time. Because of multiplexing, because of the capability of multiplexing, now we were able to request the resources, with just one connection, and it improves the speed dramatically. And this example does not show the server push. With server push, this will improve even like exponentially. But this example is not with server push. This is without server push, just a simple example that primarily shows the multiplexing feature. Okay, so going back to our presentation. So, okay, HTTP 2 was great. A lot of new things were introduced. Performance improved a lot. It was quickly adapted. It was a huge success with a lot of benefits. Still, there were fundamental problems with TCP. Like TCP handshakes still adds an overhead because you still have to establish a connection to create a persistent connection. And there is still the the problem of a request will only be sent back. The response will be given in the specific order. And HTTP 2 also ensures that the order is maintained by prioritizing the order. Prioritizing the requests. So we have seen all the great things about HTTP 2, but nothing's perfect. There are still drawbacks with HTTP 2.0. One thing is almost all the browsers now say if you're going to implement HTTP 2, if you're going to use HTTP 2, then your website has to be secure. It means you see that HTTPS in Chrome, you guys will see this lock icon next to the URL. That means that the website is secure. But if you're going to, if an application wants to use HTTP 2, it has to be secure. TLS stands for Transport Layer Security, and by making an application secure, it adds a good level of security overhead. And there is one other background, which is generally with HTTP 1.1, you can actually see the raw messages. Now with HTTP 2, the messages are not human readable because of the binary protocol. So you cannot see those anymore. So it kind of removes certain benefits of certain transparency. So that is, that's how HTTP 2 seen the benefits and the drawbacks. So next, in 2018, HTTP 3 was introduced. So with HTTP 3, it is the main difference is that the previous versions of HTTP used TCP, whereas HTTP 3 uses UDP. It is an evolution of the QUIC protocol. We'll see what QUIC is next. And it also reduces the connection establishment time. Like how I mentioned with TCP, there is the handshake to establish a connection. With UDP, you don't have that. And there is also no head-of-line blocking problem. That is the order scenario that I just talked about in the previous slide. So QUIC. What is QUIC? QUIC is Quick UDP Internet Connections. And UDP stands for User Datagram Protocol. So you can see a difference between TCP and UDP in the image, which is basically saying with TCP, you send a request and you're guaranteed that you will get a response because TCP has a lot of like features like error detection, flow control, to ensure that the message gets delivered. With UDP, it sends a message and it's like, okay, I'm done. The main difference between TCP and UDP is that UDP is very similar to TCP without the error detection part. And with HTTP 3, it's the difference between HTTP 2 and HTTP 3 is that HTTP 2 is TCP with the TLS and HTTP 2, whereas in with HTTP3. It's UDP with TLS and HTTP3. And a lot of applications have already started adapting to HTTP3. Like, for example, if you go to google.com, you can actually see that they are using HTTP3 now. If you go to the network tab and enable the protocol, you will see that they're using HTTP2 plus QUIC. That is HTTP3. So a little UDP joke here. Oh, I hope you don't get it. Okay, so that is basically what I wanted to talk about. So to do a quick summary of what we covered here, we went over the basics of HTTP, and then we looked at the different versions that are available in HTTP. We covered a good part of HTTP 1.1. We saw the benefits that were introduced, saw the drawbacks, and how HTTP2, the benefits that were introduced as part of HTTP2 solved those. And we, in fact, looked at the demo of how HTTP2 improves the performance of the page. And we had a quick glance at what's coming, which is HTTP3. These are some of the links that I used to learn about HTTP and put together this presentation. And they're mainly from Pluralsight, Wikipedia, MDN, Webmaster, some Medium articles. There are more, but these are the main ones that I refer to. So that is the end. So if anyone has any questions, I will answer them right